Hi, I'm Kirk Biles with Rajant Corporation. Today I'd like to talk to you about Rajant's Kinetic Mesh Living Network and what that is all about and how we're using it to produce operational efficiencies and application availability in the oil and gas market. So what is the living network? Well, we're all used to wireless networks that are very static, meaning you're sitting down, you're talking to your computer, you may walk a little bit, but you're not really taking that outside and moving around in an oil field or a mine or in a chemical plant, getting those applications out to your tablet or laptop. What Rajant specializes in is taking their technology and putting it on each of those assets as they move around. And we bring that infrastructure to those assets. So in effect, if you can imagine a traditional network where you have a static point, multi-point access point talking down to other points, and maybe they're moving, it's a one-to-one relationship. Where Rajant is really developing a network that's living, in effect using all of its neighbors to pass data back and forth on the network as they move using multiple frequencies. And we'll talk more about the technology here in a little bit. But what's very unique about this is its characteristics: adaptability, dynamic, smart, and productive. We've been able to show over time, putting the Rajant Living Network into these areas, that we can actually produce a very productive, efficient network. So what is Kinetic Mesh? Really, we offer two things. Our breadcrumb technology, which is the hardware, the node, and our patented InstaMesh networking software, which is really the brains inside the node itself, and making the algorithmic decisions on which way to pass data, how to avoid interference, how to avoid congestion. What the combination of the wireless node and the InstaMesh software do is they enable this true mobility that we're talking about. In effect, creating a mesh where we are talking to one breadcrumb, or many breadcrumbs may talk to 5 or 6 or 60, 100 different other breadcrumbs, making a connection to those breadcrumbs, but only passing data on the fastest direction on whatever frequency is available, making sure to avoid congestion, interference, and getting the data on and off the network as fast as possible using whatever breadcrumbs are available in the network. So what is really neat about this is most people are aware or are used to technology inside access points and clients, where the more clients you put on a network, the slower the network gets, the more congestion you have, and the more latency that builds up. So your availability of the applications you're trying to get to and use out in the field become less and less and slower and slower. Where the opposite occurs with the Rajant Kinetic Mesh network. The more breadcrumbs we put out into the mesh, the more available paths we have to load balance across the network those applications to make sure they are available to you. We don't care if one packet goes off to the right on frequency A and another packet goes off to the left on frequency B. We're going to make sure those packets get to where they're going, catch up to one another, and that application is available to you out into the field as you're moving or as you're just sitting there doing your stuff on your laptop. So think of it this way: the more nodes you add, the better the network becomes. And when you take a node out of the network, it doesn't cause any damage to the network. It continues to just pass data in a different direction. So this is what I'm talking about. So this is about as clean a picture as we could make of what we do in the most basic form. And as you can notice here, these are all of some of the different unlicensed frequencies that we use. We also have some licensed frequencies. And what we do is we pass data on all those frequencies, and we make connections between all of those nodes or breadcrumbs. So if breadcrumb E moves down from the middle down to the bottom, it stays connected to all the ones it can see, but now the costing algorithm may find that it's easier or quicker to pass data on frequency 4.9 instead of on frequency 5.8 to get the data where it needs to go. It may use all 4 frequencies in 4 different directions to make sure that it's avoiding interference or congestion along the way. So the Instant Mesh protocol is running on every breadcrumb all the time. It's not using any sort of a background controller in the closet. Each breadcrumb knows where the other breadcrumbs are and is doing a costing between them on a variable time scale. So it could be as quick as every 5 seconds, or you could set it up to look for its neighbors every 30 seconds, every minute or something. It's instantaneously using the wireless and wired connections to mesh, which is very unique in any other technology out there. So we may take breadcrumb E and want to talk to breadcrumb A. The quickest way may be to get out on the wire and connect. Or we might want to talk through E over to F, wireless, wired over to C, and then back onto the wireless. We don't care. We use the wired connections just as if they were part of the mesh along the way. What this really does is make us completely fault tolerant, highly available. So when you're passing your application data, you don't want to have something blocking it. You don't want to have it slowed down. So we're using the fastest connections between the communications hut, where your application server may be, and the wired and wireless connections along the way. So in the end here, we talk about security, monitoring, QoS, and more. These are very important in all of the applications. We manage to have some of the highest levels of security in the world on wireless. Some of our largest customers in the world are the US government. We also support all QoS and more. Our fast lane technology revolutionizes QoS, where we can actually prioritize applications that are very sensitive to time, like autonomy for vehicles, driving vehicles remotely, and make sure that that is even prioritized higher than the QoS levels. All right. So a traditional mesh, what you have maybe 2 frequencies, and you're using one as sort of the backhaul between, and then these are all moving around inside. It's more of a client access point type mesh. And as they move around, you may have congestion here. All these may be asking for a lot of data, and you're slowing down along this way. Or if this node goes down, all of these nodes no longer have a connection. It's a real problem that we see in the market right now. So multiple points of failure, multiple points of congestion, and if you have any sort of interference, everything could fall off. Where Rajant, if you went, all these points are exactly the same on this next picture. But since we're all infrastructure all the time, we don't care. We can pass data straight through the network. We could use all of the breadcrumbs along the way, multiple frequencies all the time to do that infrastructure data, making sure that those connections are always available, that we're avoiding congestion or interference. And if one breadcrumb goes down, say this one, only that breadcrumb loses connectivity, not all the rest, because they'll immediately start passing data, instantaneously pass data in a different direction to make sure that that information is getting on and off the network. So nodes talk to each other and have multiple path options. That's hugely important for what we do. In some cases, we see breadcrumbs that have 50 or 100 connections being made all the time, but we're not passing on all those connections. We're just knowing that they exist and that we can use them if we need to. So how we work in the oil and gas field. What we've been able to do is take our kinetic mesh products and put them on the static equipment as well as the moving devices and provide data out into the field. So oftentimes everybody is looking to get all of their application data on how efficient is the oil well producing, how are the drills producing, are the rigs functioning properly. All of this data becomes massive amounts of data over time. And if you can't get to it and can't get all the analytics off of it, you're wasting that much efficiency in the whole scheme of things. So, if you have a non-productive drill working out there and you don't know about it, you could lose up to a third of your operating budget in drilling. Putting in predictive maintenance models can predict how to reduce the breakdowns, the maintenance, the cost. And by setting up a mesh network, you'll never lose those connections. So an increase in production of 10% is huge out there in the oil fields. So what we find often is the minor expense of a breadcrumb connection is paid for itself, not in just months and days, but oftentimes in just hours. Once they have that connection up, they can get the information they need to effectively run the mine. So as people have invested, or companies have invested so much money in the capital expenditure to put these fracking oil rigs out there, and what am I thinking? Offshore oil rigs, and making that capital expenditure, now they've gone back to look for operational efficiencies. How do we know that we're getting everything out of all the money we put into this? So to go ahead and put our Rajant Kinetic Mesh technology out there, they can get the data on and off. They can have people in the field moving on trucks, cars, even man-wearable devices to make sure they know where people are. And you can see an increase of production along the way. So some of the applications that we're working in today: process control, making sure that everything is working the way it should. You know, the pumps are pumping as efficiently as they need to. The drills are stopping if they start bottoming out and there's nothing there. Production control, are we making sure the flow is going right through? Are we turning on and off the pressure gauges to get all the gas and oil out of the field? Production automation, they don't want to have people to go out, drive out all the way in, turn a knob here, turn a knob there. You can do all this remotely. Platform and vessel communication, we do quite a bit in the Gulf, where we have what we would call sort of a bubble around all the big rigs, the offshore oil rigs, and then Rajant breadcrumbs sit on the boats, and as they come in and out of different areas, they automatically connect and build that mesh, so they can have video onto the boats. They can actually do safety videos for people so they don't have to waste time on the rigs as they're coming in to offload employees. Vehicle routing and dispatch, fairly easy. They can, get people to go out where they need them to be, track where they are, have the connections there for their laptops. Surveillance and security is becoming a much bigger issue, especially in Southwest Texas, where you've got oil rigs going up in neighborhoods and people are running around. They've got to see what's going on. So to be able to pass that video data back in real time is incredibly important. Employee contractor communications, you can use the breadcrumbs to do tactical radio over IP, so you can actually talk over this communication device. Vehicle remote equipment health monitoring, personal safety, GPS location status check. Pretty much the same, all rolled into one there. So one case study here as we wrap up. In Southwest Texas, there's an oil field about 42 kilometers or square miles that had put up a wireless network of 900 megahertz. They had some real problems as the wind was blowing everything all over the place. They had to align antennas. They were having people go out and try and make things work. The real problem with this whole thing is they couldn't get all of the connectivity they wanted. And they were looking to have well monitoring for real-time well diagnostics, surface and pump data, onboard pump simulation, data history, and searching database load and position data. Without a steady 900 megahertz network, they couldn't get any of this. What we did is go out there and use their existing mass and put the Rajant breadcrumb network out there. And we're able to make all of the connections happen and effectively give them the application data that they needed and wanted to be able to run these wells more efficiently. The results, over 300 wells have scaled up, 125 support sites, and the customer is adding more applications as well as more well sites as we speak. So we're expecting to double in size here in the next, over 2016. So back when it first started, 300 to 400 wells, what they used was sneaker net. Basically the new guy, just out of college maybe, had to get in a vehicle and drive to every well and pull the data off the well. It took about 2 weeks. Then he'd come back and they'd stick it in a computer and they'd analyze it, and then they'd tell the guy to go out and make the changes. So by the time this all happened, they were burning up drill heads. They were having pumps that weren't pumping efficiently. They were losing hundreds of thousands of barrels of oil a day. Now, they get real-time data collection. Their analysis is immediate, so they can see things. Error is made corrections are made instantaneously, and reliability assessments, key operations. So in the end, as we look at this, Rajant Kinetic Mesh delivers the highest level of security in the industry, NSA Suite B certified, completely resilient to interference, congestion, complete flexibility and power options. Right now we're working with Tesco to do some solar and battery powered applications and installations. Fixed and nomadic all the time. Rapid deployment, low capex compared to fiber. We did a study on just if they were to roll fiber through all of these areas in the oil field, it would be millions upon millions of dollars versus us at about 20% of that. Less labor, less OSHA. Because of the way we handle things, we're IP67, mil-spec rated, and as well as ATEX rated. We can put stuff out in the field and not have to worry about it. And we work with all sorts of third-party enclosures. Thank you very much. If you have any questions, I'm happy to take them. Otherwise, lunchtime. Thank you.